Alrighty, welcome to 7.1. Now we are starting geometry. We're done with statistics and algebra. Well, kind of. We're never really done with algebra, but our focus now is on geometry. So, first one, nets and drawings for visualizing geometry. So we're going to talk about a couple different things. What a net is, an isometric drawing, and an orthographic drawing. The Common Core standard is GCO 1. No precise definitions of angles, circles, perpendicular lines, parallel, and line segments. And we'll get further into these. I don't know that we'll cover all these today. Actually, we won't, but that's the idea of this chapter, is knowing lots of these different things. Okay, so looking at this problem, it says when you shine a flashlight on an object, you see a shadow on the opposite wall. What shape would you expect the shadows in the diagram to have? So if we're looking at this right here, that's coming from this flashlight. So that's showing on this side right here, so that's going to project as a rectangle onto that wall. And then this one is shining its light on the triangle here. So this is going to look like a triangle on that wall. Okay. Fun stuff. Okay, in the Solve It, you had to see the projection of one side of an object into a flat surface, onto a flat surface. Visualizing figures is a key skill that you will develop in geometry. Okay, you can represent three-dimensional objects with a two-dimensional figure, such using special drawing techniques. A net is a two-dimensional diagram that you can fold to form a three-dimensional figure. Sorry, I'm struggling with my words today. A net shows all the surfaces of the figure in one view. So the net at the right folds into a cube as shown. Which letters will be on the top and the front of the cube? Okay, so looking at this, a cube has 6 faces, so that's why we have 6 squares here. So if D is right here, that's folding onto the side right there. C is going to be the one next to it, so it's going to be right here. And then on top of that, the one that's going to touch C and D is going to be this E. It's going to fall down on top right here. That should be E. Okay, and then the rest F should be on the bottom, B should be next to C, and then A should be on the back side. Okay, so next. The net in problem 1 falls into the cube shown on the right. Which letters will be on the top and the right side? Okay, so if B is in the front, I have to go back. Okay, so you hurry and do this. I'll flip back and figure out what it is as well. Pause this in 3, 2, 1, pause. Okay, so C should be on the right side of B, and then E should again be on top. Hopefully that's what you got. Alright, packaging designers use nets to design boxes and other containers like the box in problem 2. Okay, so what is a net from the graham cracker box to the right? Label the net with its dimensions. Okay, so we've got this rectangular prism, so this is going to look a little bit different than our cube. I'm just going to start with the front face here. I'm drawing that, so I'm going to draw that here. It's a rectangle, and I know that that is 20 centimeters by 14. Okay, and then I've got the one on the side, which is also going to be another rectangle. So it's going to look like this. Maybe not quite that thick, though. Undo. There we go. Something like that, maybe. And I know that that side length right here is 6. So this is going to be 6. Still 20 centimeters tall. Okay, and then following that around, the back side is going to be the same as the front side because it's a rectangular prism. So here we have another one that is 20 by, this is 14. Okay, and then we have this side of the box over here, which is going to be, you can put it on either of these sides. I'm going to put it over here. Let me erase this 20, move to the inside, 20. That's our last side there, and that's also 6 centimeters. Okay, but I'm missing 2. I'm missing, because I only have 4 faces here, so I'm missing the top and bottom. So the top, you can really put anywhere on here. I'm just going to put it on the first one that I made, so the face. So it's going to be another rectangle like this. And that is going to be 6 by 14 because it's got to be the same width there. Okay, and then the bottom I can just put directly below that. Erase this. And again, that should be the same size. 14 by 6. Okay. And these are all 20. 20, 20. I'm not writing my centimeters because it will look super messy, but those are all centimeters. Alright, and that's what your net should look like with the labels, dimensions labeled. Okay, this one is a triangular prism, so I want you to go ahead and try and draw the net for this with its appropriate labels, and then I will also draw it as well. Okay, pause this in 3, 2, 1, pause. Alright, so this is what mine looks like. I just started with the front face of the triangle, and then I added the rectangles onto it. So they're kind of like slanted rectangles because the triangle is not, you know, perfectly, it's slanted. Then I have this triangle here. This is actually the back. And the bottom is here. That's the 7 by 4, that's the bottom. Okay, and then these are the two sides. Side. Side. And then the front is this main one right there. Okay, so there's definitely other ways to draw this. You could have started with the rectangle on the side. Let's do very bad at drawing today. And then you could have made like the triangles off to the side like this. And then the other rectangle like that. And then the base down here. Okay, lots of different ways to do this. As long as you've got all the correct sides adjacent to each other, that should work. Okay, next we are going to talk about isometric drawings. So an isometric drawing shows the corner view of a three-dimensional figure. So it's like drawing in 3 dimensions. Okay. Let's see, you can draw an isometric drawing on isometric dot paper if you have that, which you probably don't, but the simple drawing of a file cabinet is at the right is an isometric drawing. Okay, so obviously it's not 3-dimensional because you're drawing it on a piece of paper, but you're drawing it as if it were 3-dimensional. So you're drawing the corner view. So if you're drawing this structure over here at the right, first they drew the front edges, so drawing this part here. Okay. Next we want to draw the right edges. So what I would do is drawing the right edges, basically these things here on the right side. So we have to take all of these, draw them out diagonally. They shall be parallel. Connect them all. Okay, actually I jumped ahead, but the right edges, basically all of those that are going out to the right. So right edges are talking about here, 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 and here. So that's what I've done. All of there. Draw on your right edges, and then the last step is to draw the back edges. So here, 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 here. Basically connecting all of these. Like so. So it should look something like that. Okay, so draw the front. Then you have to kind of extend it off into space with your right edges like so. I'm just exaggerating these. And then connect them all. Yeah. Okay. And then we also have what we call an orthographic drawing. It's another way to draw a 3-dimensional figure, or to represent a 3-dimensional figure. This one shows each view separately. So you have the top view, the right view, and the front view. Okay, so looking at this, actually I have done the problem for you already, but this image over here, if you were to draw an orthographic drawing, first it wants you to draw the top. So that's up here. If you just look at the top, that's all of these, that face, and these faces up here, all the ones that are on top. So the first one they've drawn is the little Tetris looking piece here. Okay, so that goes on top, and then the square is from this piece right here. Okay, and to show that those are not at the same level, they've separated it with a solid line. Okay, so notice how those are not connected. Okay, solid lines show visible edges. Okay, so all of these edges that have been shown are visible when you look at it from the top. So this is visible, and all of these are visible. Okay, so we did not draw it like this, because that would mean that it's all at the same height, and it's not in this case. So that's why there's a solid line here, to show that this piece is a different height than this piece. Oops. Okay, so that's the top view. Then we have the front view here. The front view is on the left side. You could also just call it the left view if you want, but that's going to be all of these that are facing the left. So here and here. And actually this one kind of extends back, but you're not going to be able to see that, so we use a dashed line. Okay, so we've got this front rectangle here, that goes with this guy right here. And then those are all visible edges, so that's why they're all solid. And then you can only see this square, but we know that that continues to go back behind the block, the tall block. So that's why we have used a dashed line here to show that it goes behind that tall block. Okay, so that's your front view. You're only seeing this piece and this piece. So you have solid lines there, a dashed line to show that it goes behind the block. Okay, and then last, the right view is all the ones on the right side. So here, oops, what's happening? Here, and here. So again, you have your tall view. You have the one that protrudes out like this, so that's here. Then you have the one in the back right here. Okay. And you can see all of those. So all of those are visible edges, so they're all solid lines. Okay, so the only dashed line you had was this one because it went behind instead of being able to see it. Okay, and that's all I have for now. That's 7.1, talking about different ways to represent three-dimensional objects. Alright, have a splendid day, and I hope you all take the quiz so I can give you full points. Alright. Peace out, friends.